we're going to look at solving exponential equations with logarithms, which is something we worked on today in class. So we're going to do a few examples. Basically what happens sometimes is you're not able to find a common base. And when you can't find a common base, it kind of throws everything off. So let's look at our first example here. What we've been working on, I'm going to put previously, like a TV show. Previously, we would do something like this. We had 2 to the 3x plus 1 equals 16. And what we would do is we would find a common base. So I would have 2 to the 3x plus 1. The 2 to the 3x plus 1 stays the same. And we end up finding a common base, which is 2. 16 is actually 2 to the 4th. So we would now be able to, with the same basis, set the exponents equal. Solve that for x. So 3x equals 3. Divide by 3. X equals 1. So that's what we did previously. But when you solve these exponential equations, you're not always going to have a common base. There's going to be times that we don't have a common base. So we're going to look at what happens when we don't have a common base. So let's look at our first example. And I'm going to do example number 1. And that will be 9 to the n equals 49. Now, there's no way that I can make this have a common base. 9 and 49 do not have common bases. It's not possible. So I can't solve it like I solved this one by converting the value to have the same base. It's not possible. So what I'm going to do is I'm going to use logarithms. Let me move this here so you can see a little bit better. I'm going to use the common logarithms that we've been using to solve this. So the first thing I'm going to do is I'm going to take the common log of both sides. So I'm going to take the log of 9 to the n and the log of 49. Now why can I do this? Well, as long as you do the same thing to both sides of an equation, it stays the same, correct? So it works. So now I'm going to look at these logarithms and I'm going to decide, is there some kind of property I can use here to make this a little bit more friendly? Well, remember the power rule, okay? The power rule says the log base b of x to the n is equal to n times log base b of x. We can bring the n out front. So I'm going to take this n, this exponent, I'm going to move it in front. So now I have n times log of 9 equals log of 49. All right. So my next step is I've got to isolate the n. Remember when we solve for variables, we're always trying to isolate the variables. So for my next step, I'm actually going to want to move the log of 9. One thing that's important to remember is the logarithms, log of 9, log of 49, those are just constants. They're just numbers. Even though you see log, they're just numbers. You can treat them just like any other number. So what I'm going to do is I'm going to divide both sides by logs, log of 9. What that creates for me is now n is by itself, and all I have to do is enter this into the calculator. Now, the log key is right here below the x squared key. The log key is below the x squared key. So you're going to hit log. And notice the parentheses pops up, so you have to put your value in parentheses. So I'm going to put 49. I'm going to close the parentheses, divided by log of 9. I hit enter, and there's my answer. And it depends on how many decimal places you're asked to round to. In the exercises that we have, we're asked to round to the nearest 10 thousandths. The 10 thousandths being the 4th decimal place, because you've got tenths, hundredths, thousandths, 10 thousandths. So I'm going to put 1.7712, and that is my answer. The reason that we're getting a decimal is the same reason we cannot use this method. When this is a decimal, it's not going to work out to where they have the same base. It's just not going to work. So for our purposes anyway, for solving, for our purposes, we want to make it as simple as possible. So when you can't find a uniform base or a common base, you're going to use the logs. So let's do another example. Let's do a second example here, and I'll do it on this side. So we have number 2, we'll do it right there. And let's do 5 times 18 to the 6x equals 26. Okay. This one's going to be a little bit more complicated because now we're going to have some fractions and whatnot. So the first thing is, let's get this 5 and let's move it over. We can do that. We can do that. You could also wait and take the log of both sides if you want to and use the expansion rule. Well, actually, let's go ahead and do the division first. So we'll solve it both ways. The 5 is multiplied. I'm going to go ahead and divide by 5. That way I get 18 to the 6x equals 26 over 5. Obviously, we're not going to find a common base here. So in lieu of finding the common base, we are going to take the log, the common log of both sides. So I'm going to take log of 18 to the 6x, and that's the same thing as log of the whole thing, 26 over 5. So what do I do next? Well, I have this little thing called the power rule I can use. You remember your power rules. So let's use the power rule. I'm going to take this 6x and I'm going to move it in front. So now I have 6x times log of 18 equals log of 26 over 5. Now remember, when we take these logs and there's nothing written for the base, it's assumed it's a base of 10. Okay? So now let's do the next step. I'm solving for that 6x. Remember, your logs are just numbers, so I'm going to divide both sides by log of 18, which will leave me with 6x over here. And so now, hopefully you can see this. We'll clear this one. We'll do log parentheses, 26 divided by 5, divided by log of 18, and you get 0.5704. So 0.5704. Because remember, we're rounding this to the nearest 10,000th, the 4th decimal place. And of course, your last step is going to be to solve for that x. So you divide both sides by 6. And so x comes out to equal 0.0951 because it's 06. And that is your answer. Now, I told you we would solve it multiple ways. I'm not going to solve it the other way, but one way you could solve it from here is you could keep the 5, and you could take the logarithm of both sides, separate them out using your various properties, and you'll come out to the same thing. So let's come down here and work it an alternate way. Let's just say from the beginning, I took the logarithm of both sides without dividing by 5 first. So I just went log of 5 times 18 to the 6x equals log of 26. So what would I do in this case? Well, in this case, you would have to use the product rule. Okay. So I would take log of 5 plus log of 18 to the 6x equals log of 26. I had to use the product rule to separate it. Okay? Then after that, I would have to subtract the log of 5 from both sides. So you're going to end up with log of 18, and the 6x can go in front because that's our power rule, equals log of 26 minus log of 5. That's going to put you in the same spot because this is the quotient rule. When I have log of 26 minus log of 5, isn't that the same as the log, apologize for messing up there, the log of 26 divided by 5? And here we have the same equation that we had up here. So you could do it either way. but you still have to apply the power rules and the quotient rule and the product rule. So that is how we solve exponential equations using logs.